Hello friends, we have a very interesting question today. We are asked to calculate the length of the red line, that is this line segment here. We have the length of this tangent segment to be 7 meters. The size of this angle is 75 degrees and this angle here is a right angle. From here they said area of circle equal to 1.54 multiplied by 10 raised to the power minus 4 kilometers squared. So how can we solve this? How can we calculate the length of the red chord? Let's assume its length to be x. Well, it is very simple. We start with this quadrilateral here. It has all its 4 of its vertices on the circumference of the circle. That means it is a cyclic quadrilateral. We know opposite angles of the cyclic quadrilateral are supplementary. That is, they must sum up to 180 degrees. We can see this angle and this right angle are opposite to each other. So by this rule, the sum of the two angles must be 180 degrees. So since this is 90 degrees, this must be 180 degrees minus 90 degrees, which is 90 degrees. That is also a right angle. And the next thing we are going to do, we draw the diagonal of the quadrilateral from this vertex to this vertex here. Now look at this triangle. It is a right angle triangle. So we can use a circle tool. Taking this angle as theta, say A, this is the opposite and there is the hypotenuse. From here, sin theta equal to opposite of our hypotenuse. Theta is A, opposite is x, and hypotenuse, let's say y. So sin A equal to x over y. But this side y here, if you look, it subtends this right angle to the circumference. The only chord in a circle that subtends a right angle to the circumference is the diameter. So this here is a diameter. The diameter is actually 2 radii. So if we locate the midpoint of the diameter, which is the center of a circle, this line segment and this are radii. So y equal to r plus r. R plus r is 2r. Substitute here. So sin A equal to x over 2y. Now what is the radius of the circle? We don't know. We come here to this our equation. Area of circle equal to 1.54 times 10 raised to the power minus 4 kilometers squared. The formula for calculating the area of a circle is pi r squared. We equate pi r squared to this 1.54 times 10 raised to the power minus 4 kilometers squared. So pi r squared equal to 1.54 times 10 raised to the power minus 4 kilometers squared. We know 1 kilometer is equal to 1000 meters. Square both sides. Now 1 kilometer all squared equal to 1000 meters all squared. 1 kilometer all squared is 1 square kilometer. And 1000 meters squared is 1000 meters times 1000 meters, which is 1 million meters. 1 million is 10 raised to the power 6. So it is 10 raised to the power 6 meters squared. And 1 kilometer squared equal to 10 raised to the power 6 meters squared. Divide both sides by kilometer squared. Here kilometer squared cancels kilometer squared. So 1 equal to 10 raised to the power 6 meters squared over kilometer squared. Now 1.54 times 10 raised to the power minus 4 kilometers squared multiplied by 1 doesn't change it. And here 1 equal to 10 raised to the power 6 meters squared over kilometers squared. Replace this one with 10 raised to the power 6 meters squared. So pi r squared equal to 1.54 times 10 raised to the power minus 4 kilometers squared times 10 raised to the power 6 meters squared over kilometer squared. This kilometer squared cancels this kilometer squared. 10 raised to the power minus 4 multiplied by 10 raised to the power 6 by indices is 10 raised to the power minus 4 plus 6. Minus 4 plus 6 is 2. 10 squared is 10 times 10, which is 100. 1.54 times 100 times meter squared is 154 meters squared. So pi r squared equal to 154 meters squared. Pi is 22 over 7. 154 is 22 times 7. This 22 cancels this 22. So 1 over 7 times r squared equal to 7 meters squared. Multiply both sides by 7. Here 7 cancels 7. While here 7 meters squared times 7 is 49 meters squared. So r squared equal to 49 meters squared. Take the square root of both sides. Here square root of r squared is r. While here square root of 49 meters squared is 7 meters. So r equal to 7 meters. That is, this radius and this are 7 meters each. Substitute here. Now sin A equal to x over 2 times 7 meters. 2 times 7 meters is 14 meters. So sin A equal to x over 14 meters. Now come to this chord here. Draw a line perpendicular to it, to the center. Assume its length to be z. Now look at this triangle. It is also a right angle triangle. So we can use the SOHCAHTOA. From this angle, this is the opposite, and this is the hypotenuse. We know sin theta equal to opposite over hypotenuse. Theta is A, opposite is Z, and hypotenuse is 7 meters. So sin A equal to Z over 7 meters. Recall here sin A equal to x over 14 meters. Substitute here. Now x over 14 meters equal to z over 7 meters. Multiply both sides by 14 meters. Here 14 meters cancels 14 meters. While here this 14 meters divided by this 7 meters is 2. Z times 2 is 2z. So x equal to 2z. Now what is z? We don't know. Let's look at this tangent here. From the cycle theory, we know there is a rule that the tangent of a circle is perpendicular to its radius through point of contact. This here is the point of contact. So by this rule, if we draw the radius of this circle to this point of contact, this angle will be a right angle. The radius of the circle we know is 7 meters. That is, this line here is 7 meters in length. The next thing we are going to do, we come here, draw a line that connects this point and this point. Now look at this triangle. It is a right angle triangle, and we have this side and this side to be equal in length. That is, it is an isosceles right angle triangle. The angles of an isosceles right angle triangle are 90 degrees, 45 degrees, and 45 degrees. So since this is 90 degrees, this angle and this must be 45 degrees each. But recall, this whole angle is 75 degrees in size. So since this part is 45 degrees, this must be 75 degrees minus 45 degrees, which is 30 degrees. Now from this triangle, we can use the Pythagorean theorem. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this side here. Assume its length to be v. So by Pythagoras, v squared equal to 7 meters all squared plus 7 meters all squared. 7 meters all squared is 7 meters times 7 meters, which is 49 meters squared. 49 meters squared plus 49 meters squared is 2 times 49 meters squared. So v squared equal to 2 times 49 meters squared. Take the square root of both sides. Here square root of v squared is v, while here square root of 2 times 49 meters squared is root 2 times 7 meters. Root 2 times 7 meters is 7 root 2 meters. That is, the length of this side is 7 root 2 meters. Now look at this triangle. It is a right angle triangle. So we use the SOHCAHTOA tool. Taking this angle as theta, this is the opposite, and this is the hypotenuse. We know sine theta equal to opposite of a hypotenuse. Theta is 30 degrees, opposite is z, and hypotenuse is 7 root 2 meters. So sine 30 degrees equal to z over 7 root 2 meters. 30 degrees is a special angle, and its sine ratio is 1 over 2. So 1 over 2 equal to z root 2 meters. Multiply both sides by 7 root 2 meters. Here 7 root 2 meters cancels 7 root 2 meters. While here 1 over 2 times 7 root 2 meters is 1 over 2 upon bracket 7 root 2 meters. So z equal to 1 over 2 upon bracket 7 root 2 meters. Come to this our equation, x equal to 2z. Substitute the value of z. So x equal to 2 times 1 over 2 upon bracket 7 root 2 meters. 2 times 1 over 2 upon bracket 7 root 2 meters is 7 root 2 meters. So x equal to 7 root 2 meters. That is, the length of this straight line which we are asked to calculate is 7 root 2 meters. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.